Hi all, welcome to new class. Today's class is about transistor configurations. When transistors are used in practical circuits such as amplifiers, oscillators, etc., we require four terminals. That is, two for the input port and two for the output port. But the transistor has only three terminals, and this difficulty is overcome by making one terminal common for the input and output ports. And the term common is used to denote the region that is common to the input and output circuits. So, the transistor has three configurations, and that are common base, common emitter, and common collector. So, in common base configuration, the base is common to both input and output ports, and in common emitter, emitter is common to both input and output ports, and these are the symbolic representations. And in common collector, the collector is common to both input and output ports. Next is the comparison between configurations of transistor. So these are the characteristic parameters. Then this is common base, then common emitter and common collector. So input dynamic resistance. It is low in the case of common base, then moderate in common emitter, high in common collector. Next is output dynamic resistance. It is high in the case of CB, moderate in CE and low in CC. Next is current gain. It is less than 1 in CB, high in CE and very high in CC. Then voltage gain, moderate in CB, about 500 in CE and less than 1 in CC. Next is power gain, medium in CB, highest in CE and medium in CC. Then phase relation between the input and output. In phase in CB, out of phase in CE, then in phase in CC. Next is applications. CB is used for high frequency applications, example RF amplifier. Then CE is used for audio frequency applications, example voltage amplifier. Then CC is used for impedance matching and voltage buffer. Then power efficiency is low in the case of CB, moderate in CE and high in CC. Next is common base characteristics of transistor. So this is the experimental setup for the common base characteristics, and the characteristics include input characteristics and output characteristics. So here VEE and VCC are two regulated supplies, DC supplies. The input CB characteristics are plotted between the emitter current IE and the emitter to base voltage VEB, and for constant values of VCB, that is collector to base voltage VCB. So input CB characteristics the plot between IE and VEB, keeping VCB constant, and the experiment is repeated for different values of VCB. Here we get plot like this, that is with VCB is equal to 2 volt, we get a graph like this, and if increase this VCB to 4 volt, then the graph is shifted to the left. So in this way the input characteristics is got. So in the output characteristics, so next is output CB characteristics, and output characteristics are plotted between the collector current IC and collector to base voltage VCB for constant values of IE. So here also IE is kept constant, then plotted between IC versus VCB, then IE is changed to another values and again we plot IC versus VCB. So here this is the saturation region and this is the active region and this is the cutoff region. From the input CB characteristics, the reciprocal of the slope of the curves gives the values of dynamic input resistance. That is, dynamic input resistance Ri is equal to delta VEB divided by delta IE, keeping VCB constant. Then from the output characteristics, we get dynamic output resistance RO is equal to delta VCB divided by delta IC, keeping IE constant. Another important expression is common base current gain alpha, and that is equal to delta IC divided by delta IE, keeping VCB constant. So the current gain is the output current divided by the input current, keeping the output voltage constant. Next is common emitter characteristics of transistor. So this is the experimental setup for the common emitter characteristics, and here we have to find both the input CE characteristics and output CE characteristics. So input CE characteristics are obtained plotting VBE versus IB, keeping VCE constant. So input characteristics is the curve between VBE versus IB, keeping VCE constant. Then the output CE characteristics is the plot between VCE versus IC, keeping IB constant. So in general, input characteristics is the plot between input voltage and current, keeping the output voltage constant. Then output characteristics is the plot between output voltage and current, keeping the input current constant. So this is the input CE characteristics and this is the output CE characteristics. So here VCE is kept constant, then plot is taken between IB versus VBE. So here if we take VCE is equal to 2 volt, then we get a plot like this, and if we increase VCE to 4 volt, then the graph is shifted to right side. So this is the input CE characteristics, and from the input CE characteristics we get a dynamic input resistance Ri, and that is equal to delta VBE, that is the reciprocal of the slope. So delta VBE divided by delta IB, keeping VCE constant. Then this is the output CE characteristics, and it is the plot between IC versus VCE. And note that here IB is in microamperes and IC is in milliamperes, and this is the saturation region and this is the cutoff region and this is the active region. So here also IB is kept constant and different values are taken for different values of IB. Then from this output CE characteristics we get a dynamic output resistance RO, and that is equal to delta VCE divided by delta IC, keeping IB constant. Then another important factor is common emitter current gain beta, and that is equal to delta IC divided by delta IB, keeping VCE constant. That is the output current divided by the input current, keeping the output voltage constant, and that is equal to the common emitter current gain beta. And the relationship between beta and alpha is beta is equal to alpha divided by 1 minus alpha, and alpha is equal to beta divided by 1 plus beta, and alpha is always less than 1. Next is the common collector characteristics of transistor. So this is the circuit diagram for the common collector characteristics, and the input characteristics is the plot between VBC versus IB, keeping VEC constant. So this is the graph obtained after plotting IB versus VBC. So keeping VEC constant. So if we give VEC equal to 5 volt, then we get this plot. Then after increasing the value of VEC, then the graph is shifted to the right side. Then output characteristics is the plot between IE versus VEC, that is IE versus VEC, keeping IB constant. So this is the plot obtained, and this is the saturation region, this is the cutoff region, and this is the active region. So that is about the characteristics of transistor configurations. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.